Hello guys, welcome back to my YouTube channel. We are still under Mechanotechnics N6. This is the first part. We'll be dealing with the bend bricks. Alright, and then I'll advise you guys, you can become a part of the family by subscribing to my YouTube channel. Then you'll become the part of the family and click the notification bell after you have subscribed. Or if it is your first time watching my videos, kindly subscribe to my YouTube channel. I will appreciate your support, and then I will keep on posting more content for you guys. So let us indulge in this video together. We have given example 2 here, right? Then read as follow: the layout of a bent brick as used on this is an elevator is shown in figure 3.5. The coefficient of friction between the band and the drum is 0.25. The contact angle of the band is 240 degrees and the drum diameter is 600 millimeter. Calculate. Then question A, the torque exerted when the drum rotate clockwise. You see, when rotate is rotating clockwise rotation, right? That is what we're given there when it's rotating clockwise, right? So the scratch that we're given here, it is the scratch. You see the scratch. This is the scratch. So when we should check when it's rotating at clockwise. If we're rotating it clockwise, check note guys. You see now the, remember, for it's supposed that if you have your drum saw, suppose this your tensions, they're supposed to be at the lever or at the beam. They're supposed to act at the 90 degrees. Let's say you're given your beam like this, or your lever, you're supposed to act exactly at the 90 degrees. It's supposed to act here. Let me erase. It's supposed to act, let me just do like this, 90 degrees. Let's say this is your beam, supposed to act here 90 degrees. Even if it also T2 or T1, it must act, this tension T1 and T2 must act 90 degrees via what? On the beam here guys, on the beam, on the lever, supposed to act on 90 degrees, supposed to make 90 degrees angle, right? So as you can see here, we are not given 90 degrees. Check it, it makes 60 degrees, but supposed to become 90 degrees guys. It's supposed to act via 90 degrees, it's supposed to act on 90 degrees, but now it does not act on 90 degrees. So if it's like this guys, you'll consider the components. If it's acting, if your tensions guys T1 and T2 is acting on the certain angle, it must always become 90 with the lever. But if it's acting on the certain angle, we'll use our component, we'll apply our component or trigonometry component. You'll use vertical component CV, whereby vertical component guys will always, if it's given like this guys, is always the component guys, it's always equals to the vertical one, right? It will always be equal to, it's always equals to T, depend on what angle, depend when you are calculating via T2 or T1. But let's say, for argument's sake, let's say T2 will be T2 multiplied by sine of that certain angle. That angle is what is 6. Okay, let me just make a formula. Will be VC will be equals to the certain tension we don't know, multiplied by sine into that angle. So you'll use this formula guys. This tension will depend whether it's T1 or it is T2, will depend, but this is what you're supposed to use. But if you are using cos, if you want to use cos, you must have this angle. If you are given 60, you have it to become 130. But do not you use this extra, apply sine, you'll be fine. If you want to use cos, there's no problem, but I advise you to apply this, use the sign vertical component. We'll use the vertical component since this is acting at a certain angle, our tension. We use what? Vertical component. We'll use that formula. Here it will depend whether it's T1 or T2. It will depend, but as far we know what we're supposed to use. So they say this is rotating at anti-clockwise, guys. Rotating or at clockwise, rotate clockwise. If we take this rotate clockwise, the rotation of this spring is like this. That is the rotation clockwise. I've said T1 will act in the same direction as the beam. If it's rotating like this, T1 must also follow the same position, the same direction. T2 must oppose the direction. T2 must oppose the direction of the rotation of the drum, so of the bend. So T1 must be here, will act. Remember, this is rotating like this. If you take, is rotating like this drum. So T1 must act in the direction of the rotation. Also, T1 will be acting at this direction of this arrow, but T2 must act in the opposite direction of the rotation. This will be T2. This is what is T1, guys, right? Will act in the T1 will act in the direction of the rotation. T2 will act in the opposite direction. You see this arrow will oppose. If remember, if I continue, see, if I do that, then here is T2. You see, will act in the opposite. But check T1. Remember, this is an arrow. Will continue like this. That is the rotation. Check T1. If I take this arrow here, you'll see what will make. It will point in the same direction with the rotation, but T2 will act in the opposite direction, or will point in the opposite direction of the rotation. Take note of that. Take note, please, guys. Take note about that. Right. All right. So we should rotate. We're supposed to rotate this drum, guys. But now, as you can see, it's acting where on the 60 degrees. So this have said now, since this is said is rotating clockwise like this, then this one will be what? T2. Then this one here will have T1. So T2 will be this tension, isn't it? Is acting at a certain angle. So that means for us to calculate we're supposed to use vertical component. Remember, we'll use our calculation using vertical component. Will be what? T2. Remember, the formula is T multiplied by sine theta, right? But now remember, we're focusing where this is T what now? T2. Then you can say VT. This vertical component also will be what? T2 multiplied by sine theta. You check, guys, there. All right. Let's say, for example, you want to find the component at this part, guys. At that part will be T vertical component at this point, at this part of the T1 will be vertical component will be T1 multiplied by sine 60. But now, obviously, I'm just checking the component there. Remember, I'm taking the rotation. T2 will be calculated like that, like this. All right, guys. Hopefully, you'll understand this. Hopefully you understand this. All right. So why I'm doing this is because, check here, guys. All right, is because why I'm focusing on T2. Why I'm not using T1 is because, guys, the ratio T1 over T2 is equals to E coefficient of contact angle multiplied by coefficient of friction. So T1 can be formulated by multiplying that side. It will be T2 multiplied by E, like that. So you see, already we'll have T1. So we don't know what is T2. T2 will find, we're supposed to use this component now. We'll consider our components there. We'll consider our component here. We'll consider our vertical component. That is why I made that. Okay, nevertheless, let us try and answer this question right as far as possible. A, the torque exerted when the drum rotates clockwise. All right. So let me zoom in again. All right. The clock when it's rotating clockwise, right? When the drum is rotating what? The torque when it's rotating clockwise. Okay. We have here it's A. when it's rotating clockwise. Rotating clockwise, guys, right? Okay, all right. We're supposed to find. I've discussed about that. We'll find the vertical component. I said vertical component of suppose find the vertical component of T2. Why? Is because I've said T. Okay, let's start here. Start by information. Start by doing ratio. Maybe you'll understand this. T1 over T2 is equals to E coefficient of friction multiplied by the angle of contact there, as you can see, right? So if you can see here, we have T1 over T2. E coefficient of friction we are given in our formula, in our statement, is 0.25. The angle of contact is 240, but remember, must be in what? In radians. So we'll do must be in radian. So coefficient of friction there, as you've seen there, guys. Remember, for finding, remember, okay, if you start by this, guys, you'll be okay, it's fine. You'll be stuck, but you suppose no problem. You'll use, okay, it's fine. Coefficient of friction is 0.25, right? Now the angle, this, right, guys, we said to supposed to be in radians. Remember, we've given 240 degrees, right? You must divide this by 57,3. You divide by 57, this will be not in radians, right? So you're supposed to divide like that. You divide this. So you can do it same time if you want, guys. You can do it same time. You can multiply also that this angle by 240. You can do it. You can put it. You can punch it at the. We can do it once like this. Then we punch this on our calculator. If you punch this on your calculator nicely, you'll get this to be equals to what? This side will be 2,85, right? So remember, is T1 over T2. Then you make T2 this, T1 the subject. You see, you can multiply. You can have T2 T1 now. T1 can be, you multiply that side, will be 2,85 T2. You see. Now we see everything. What about T2 now? How can we get T2? Remember, the torque we're supposed to calculate, guys. The torque is given by T1. Sorry about that alarm. Given by T1 minus T2 multiplied by what? By the radius there. So for us to have T1, we're supposed to know the value of T2. How can we get T2? All right, then now that is when you will use your vertical component, but now you'll apply what? Your moments. Now you have given this, you will apply what? The moments, your moment. That is when now you'll find this here on this diagram. And then however this, you'll apply the moments, guys, your moments, right? You'll apply the moments, and then do not use T. Then you'll use your vertical component will be this. Now you'll use the vertical component. The force that will act here will be vertical component. You'll take it, and then this vertical component will be acting here. Now you'll have your vertical component there at the 9, will act exactly at 90 degrees upwards. You'll have your components there. So that component that will act here going upwards will be acting at this distance from the point, from the fulcrum now. All right, so we create our beam. This is a beam, guys. You know the laws of, this is the beam, this is your beam. You will take the moment about about point A, this from the pivot. This is the pivot. You take moment about the pivot. You can call this pivot maybe A, for example. Take a moment about from the pivot, or a zero position, or this is 0. You can take it from the 0 position. All right, so we have that beam is like this. Now this thing, guys, if you take the moment there, we must be, check note, if you take the moment there, you must be very, very, very wise, right? take the moment there. You know, this is like a beam. This is, remember, this will be like a force. This is a mass. You can convert that to become a force. You'll have a force here. Remember, force is equal to mg, is acting downwards. All right, and then we take the moment from the what, from the zero region. You'll calculate that is the distance. The distance would be sum of 0.2, 0.5. You understand? Then you'll have here your vertical component that will take place also here, whereby the vertical component there, your vertical component is here. Also, you'll have a vertical component here, but now remember we won't focus now, but just for illustration, you'll have a vertical component again there. If you know your maths like this, if you know your physics, your beam will be like this, right? So all right guys, so I can create a beam for you guys then. Let me just create it here on the bottom. This is what we have. From there until there, I'm just acting. This will be the force that is acting there. Then we have there, from this there down, we'll have vertical components. Whereby this vertical component is T2 multiplied by sine theta. Then okay, now theta is what is 6. All right, as we move there, it goes here. At going down here, we have point A. This is our pivot, that is our reference place that will take over there. We'll consider that. So by taking moments using this beam, we'll have to take some moments there. All right, can do like this. You understand? Let's take the moment now. This, remember, this is F. It's a force which is equal to mg. All right, so we take the moment. The distance there, it was what, 0.2. Okay, from here, the distance there is 0.2 meter. From there till there is 0.5. Right. By the way, also here we will have your vertical component, but now let us will not focus on it due to what already we have T1 there. So this is how you'll have your beam. Now you take up the moments, calculate the moment, take the moment about here, this point. Let me call up this point here, let me shade it. Can say this is what, it's A. Take the moment about A or 0 reference, because they was given to be 0. Okay, take a moment, take moments about 0 point there. Oh, all right, which is this there, which is that, from that point there. I've highlighted it. All right, so let us check. You know, sum of clockwise moment is equals to the sum of anti-clockwise moments. All right, so let us go. Now this is a beam, because you know now the moments. You know how to deal with the moments using it. So clockwise, we'll have this will, F will rotate like this in the clockwise direction, F. You understand? But note, T vertical component will act upwards. Remember, because the tension is acting upwards. This one will be acting where, upwards like this. It's the same as like we have a force here on the bottom. It's acting upwards. can take this and write it here down. It's the same as like it's acting down, it's acting upwards. This is what is T2. Is is T2, but which is vertical components, is acting upward. This will act anti-clockwise. We have one force. This is acting upwards. If it's acting upwards, you see, will act like that anti-clockwise, cause the beam to rotate like that. So we have that, which is force, which is mg, multiplied by what? The distance from the reference. You add 0.4 plus 0.7, will multiply by 0.7, it's equals to, now you focus on the anti-clockwise one. This is the one, this force is acting upwards. Remember, since it's acting upwards, if you are confused, you can write it down here. It's one and the same thing. You can write it at this position like this. You can do like this if it's confusing you, right? Then this is a vertical component, whereby is T2 sine 60 degrees. If it's confusing you, if it is confusing you like this. So this force now is acting where? It will be anti-clockwise, right? Acting on the, so not clockwise, it's acting on the anti-clockwise like this. It's acting on the anti-clockwise, as you can see. It's acting anti-clockwise. Then that will be what? Vertical component, whereby is this, whereby is vertical component multiplied by what? The distance from the 0 point here till the 0 point what? 0.2, right? So the mass, we know what is the mass. The mass that we've given, remember here we've given the mass, which is 4.5, the 4.5 kg. We've given the mass that is placed here, the mass like that, which is 4.5 kg. So the mass will be 4.5 kg. G is the acceleration due to gravity, is 9.81 multiplied by 0.7 is equal vertical component. We said it is what is equal to this, the vertical component, right? Then we'll have the T2 multiplied by sine 60 degrees multiplied by 0.2. So let us get T2. We make T2 the subject. The aim is to find T2. Okay, we will divide both sides by sine 60 degrees multiplied by 0.2. Divide both sides by sine 60 times 0.2. This and this will cancel. Therefore, T2 will be, if we punch this, we'll get that T2 to be equals to 178 41 Newton, like this, 178,41 Newton. All right, so we have T2, but we've started here, guys. We wanted to have what now? T1, because on T2 we have the aim is T is T1. Here is T1. We did the ratio. Then from this ratio, now we can substitute what we know from what we have, from T1 is equals 2.85. T2 is what we have just calculated right now currently. Therefore, T1 will simply equals to 508.5 watt Newton. Then we know the torque. We said the torque is equals to T1 minus T2 multiplied by the radius of the drum. Then here we have T1 is 508.5 minus T2, whereby T2 is same as that, it's 178.4. Then the drum, what was the radius? What is the radius of this? Oh, what is the radius? We go to our statement again. what is the radius of this. You've given that the diameter, you've given the diameter to be this. Okay, 600 millimeter divided by 2, you'll get 300 millimeter. Then this for must be in meter, divide by 1000 will be 0.3. Then we multiply this by 0.3 by 0.3. Therefore our torque, ladies and gents, then our torque will simply equals to what? We punch the, oh sorry about that, we punch this. I'm trying, all right, I wanted to highlight like this. Then our torque there nicely so will be 999, then is measured in Newton per meter. So this is how it goes, guys. This is how it goes. We find the torque, right? The torque there, the one that is acting at the when is rotating our thing clockwise. Hopefully you understood this, guys. So this is how it goes, guys. All right, so you see now we have changing again the position. This is now be the torque when the drum rotates anti-clockwise. All right, now you change thing. Now it was rotating clockwise, now you change it, will rotate anti-clockwise now to the left. Remember, anti-clockwise is when your arrow is pointing where to the left. Remember, here is left, clockwise is here to the right. If your arrow is pointing like this, is pointing towards the right, this is clockwise, this is anti-clockwise, means to the left. So that is anti-clockwise. So you'll change now. Remember, I said T1 will be acting in the direction that they will acting in the same direction of the rotation of the drum. Since the drum now is rotating at this direction, you see the drum is rotating like this, guys, at that direction. It's rotating at that direction. That means T1 will act in the same direction with that. So that means we'll change this one now. This tension now will be no longer be T2. Will be what? Will be T1 now. Then this one will change now. Will be no longer. Remember, I was supposed to oppose. This will be T2 now. This is going to be T2. That is going to be what? It's going to be T2. So how so far? Now we'll change we scratch again our diagram here. We'll have a vertical component, but the vertical component now will change. Here we'll have a vertical component. Since it's acting on a certain angle, there will have a vertical component, but now our vertical component now will change, will become T1 instead of T2. You see, will become T1 instead of T2, multiplied by what? Sine 60. All right, multiply by that, guys. You just change, you understand. This will be like this now. All right, then we have this force is still there. This will be force that is acting. So we'll have our vertical. So how can I scratch this? Let me sketch it again. From here we'll have our force does not change. It will be acting downwards. There it's our beam until there to the point O. Remember, here we'll have this force acting downwards, whereby the force is equals to mg. Come here, we'll have a vertical component. Remember, the vertical component must act upwards. You can write it here on the bottom if you want. Remember, it's acting upwards. You can write it like that. You can write it here. Goes like that, upwards. Or let me write it. Remember, from this distance, there you have your vertical component acting where? Upwards here. No, right. You have a vertical component, which is, we have our vertical component there. All right, then this is our point of this is our pivot. Here we have the pivot now, right? This is a pivot. Then you take up the moment. The distance from here until there is 0.5. The distance from there until there is 0.2. So can grab this now. If I was you, I was just going to oppose everything. All right. But if it is someone, if I was someone else, guys, I was just going to change everything here to oppose them. But anyway, let us go then and check now where it is B. Everything will change now, guys. Everything will change. I'm just showing you this graph. Okay, we can start again by say T1 over T2 is equals to, remember, because now everything is changed now. Everything. But you can continue, but the ratio will be the same. It won't change. This will be still, the ratio will still be the same. Remember, because we'll be using the same value. Remember, T1 is still going to be, it won't change. Still, the ratio will still have, going to have the same ratio that we had, which is 2,85 T2. It won't change. The aim again is to calculate T2, the aim, but now we're taking this anti-clockwise. Okay, we'll take moments via anti-clockwise. All right, let me take my beam here on the bottom little bit like this. All right, so sum of clockwise moments must be sum equal to the sum of anti-clockwise moments. All right. This is actually rotating where we'll rotate on the, as you can see, will be on the anti-clockwise, right? This will be rotating, this now will be rotating where via clockwise, right? Will be rotating via clockwise. No, I'm mad. This will be rotating anti-clockwise, but this will be rotating, will be forcing, or this will be rotating clockwise. This is rotating clockwise, guys. This is clockwise to the right. What is wrong with me? Remember, the rotation like this, if the air is pointing towards the right, is clockwise, but this now will rotate like that anti-clockwise. Okay, it's fine. You know your beam, guys. You know, it's not something new. So we come clockwise moments. Remember, we have our mass here. I did not draw it, but we have that mass here, which is 4.5 kg. We know that we come, this will be rotating like this clockwise. We know that will simply equals to mass, that one multiplied by the distance. The distance is still the same. From the 0.7 we add this distance. Or let me just not waste time, just remember the mass there is 4.5 multiplied by 9.8. I can just substitute one. I can substitute this to be, we know this will be force, will be that force, whereby this force is this, is denoted by, we denoted it by like that force. Or let me just take you step by step. We have the force, guys, there acting on the distance of 0.7 from here and goes there here. Then this will be equals to anti-clockwise. This one will rotate the beam anti-clockwise. This pulley will be rotating it anti-clockwise. Remember, this is CV. Now CV has changed, is T1 now, multiplied by sine 60 degrees. It's become now T1, is no longer T2, multiplied by sine 60 degrees, multiplied by the distance from there is what is 2, 0.2. This will be 0.2, right? All right. This is what we have, but the force is mg. So it is mg. Here will be 4.5 multiplied by 9.81. multiply by our distance, which is 0.7. Then we have t1 multiplied by sine 60 multiplied by 0.2. Then let's make t1 the subject. Now we'll have t1 as a subject. We divide by sine 60 multiplied by 0.2 divide by sine 60 multiplied by 0.2. This will go like that. Then you punch this on the calculator. Therefore t1 will be equals to 178.41 Newton. You see what's going on? Hopefully you see what's going on. You've just switched everything. Remember, this value before it was 42. It was 42 firstly. We have just to change it. But anyways, let us take it step by step the way we know it. We have this now. But now remember, we had our ratio. We still have our ratio, the one that we have started with. All right. Okay. Now we have T1. We want T2. Okay. If you want T2, I'll divide by 0.85. Both sides divide by 0.285. This will cancel. Therefore, T2 will be equals to T1 over 2.85. What is T1? T1 is what? Here is T1 now there. It's 178.41 divided by 2.85. All right, then T2 will be equals to 62.6 Newton. All right, now we know calculating now our torque. Torque, we know this is T1 minus T2 multiplied by the radius. Does not change, is the one that we know, which it was 0.3, right? T1 now is, it is, here is T1 178.41 minus 62.6. The radius, it was 0.3. We know that. Then how this now, the torque will be 34.74 Newton meter. Remember, it's measured in Newton meter. Remember, this one now is the one that we've taken the rotation as an anti-clockwise. It's an anti-clockwise. So that's how it goes, guys. So that is it. Then you've scored all of your marks. So thank you, guys. By the way, thank you for watching. Thank you for watching, and please if you have not subscribed to my YouTube channel, please subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video, guys. Right, become the part of the family. As you can see, guys, there, I'm still new. This channel is still new, so by subscribing, you give me the spirit to post more. You show your engagement towards me, and you're appreciating what I'm bringing towards you. By subscribing, showing that you are grateful, then I'll bring more content. You make me to upload. As much as you guys, you subscribe, for me, it's not a problem. I can upload every day. Can upload every day. So if you subscribe, I'll keep pushing more videos, guys, for you. Nice contact, right? Thank you. Nevertheless, feel free to comment and to share this to your fellow classmates. All the best.